This section is on weighted averages. A weighted average is one in which different data in the data set get different weights or importances. For example, a batter's slugging average is computed by 1 times the number of singles, plus 2 times the number of doubles, plus 3 times the number of triples, plus 4 times the number of home runs. This gives a home run more importance than a triple or a double or a single. Let's take a look at an example of this in practice. Davis hit 59 singles, 16 doubles, 1 triple, and 6 home runs so far, I should say, since I collected this data before the season was over, so far in the 2014 season. His total number of at-bats was 276. That's what we're going to measure his success against. So let's compute his slugging average. So SLG, his slugging average, 59 singles. So 59 times 1, plus 16 doubles, 16 times 2, plus 1 triple, 1 times 3, plus 6 home runs, 6 times 4. Now notice that in slugging averages, this is the way baseball does it, they use the weight as the number of bases that the runner gets to. They didn't have to choose this. This is just the way that baseball does it. You could have chosen different weights for these. You could have said a home run is so important because it scores points. It's worth 10, and so on. The weights are just chosen based on what you're trying to accomplish. But in this case, the slugging average is actually computed using the number of bases, so 1, 2, 3, and 4. And we divide by the number of at-bats. So let's go ahead and multiply the top together. We're going to get 118 divided by 276, and if you divide those, you get 0.427. So 0.427 is his current slugging average. Let's look at another type of example. Sam wants to buy a new camera and decides on the following rating system. So he's going to rate image quality as 50% importance, battery life is 30% importance, and zoom range is 20% importance. Notice that together these add up to 100%. So our total amount of weight is 100% or 1. Therefore, what we're going to do is multiply the weights by the score in each of the categories and divide by 1, 100% being 1 weight total. So let's try the Sony. See what score this would get. The Sony is going to get an 8 out of 10 for image quality. That's worth 50%, 0.5. Plus, it's going to get a 6 out of 10 for battery life, 30%, so 0.3. Plus a 7 out of 10 for zoom range, so 20%, 0.2. If we add all of those up, the Sony gets a rating of 7.2 on Sam's rating system. Alright, now the Canon gets a 9 for image quality, so 9 times 0.5, plus a 4 for battery life, so 4 times 0.3, plus a 6 for zoom range, so 6 times 0.2. If we add all of that up, we're going to get 6.9. So this one gets a rating of 6.9 on Sam's scale. Now, I am dividing. I should mention all of this right here is divided by 1. Divided by 1 because we have a total of 100% of the weights being included. So just like the last example, we are averaging, so we're dividing by some value. In this case, the value we're dividing by is 1, symbolizing 100%. So on this scale, with these criteria, Sam should pick the Sony. Has a higher rating. Alright, let's check out the last example. Another common use of weighted averages is calculating grades. In a Math 039 class, classwork is worth 5%, homework 15%, quizzes 5%, projects 5%, exams 50%, and the final 20%. Notice that if you add all of this up, it is equal to 100%. So the question is, if Jackie has a 75% on her classwork an 82% on her homework and scores of 71, 63, and 81 on her exams, what is her current grade in the class? Okay, so her current grade in the class is going to be calculated without knowing all of the grades for all of her assignments. I only know some scores for classwork, homework, and exams. So together, these make 70% of her overall grade. Okay, so let's get started. We have classwork, 75%, times its weight, 5%, so 0.05, plus homework, her average is 0.82, times the homework weight, which is 15%, plus her exam average. So we're going to compute her exam average like we would normally compute an average, add all the scores, 71 plus 63 plus 81, and divide by the number of points possible. Presuming it was 100 each time, it would be 100, 200, 300 as total points possible. It's going to get us her exam average, multiply that by the exam weight of 50%. Now we're going to have to divide all of this by 0.7 because it's only 70% of the overall grade. There are some grades that are not factored in. So if you multiply all the numbers across the top, you get about 0.5188 divided by the 0.7 gives us 0.7411. So it looks like Jackie's current score is about 74.1%. That would give her, according to the grading scale, she would be currently getting about a 2.0.